0. So that's why v1, v2, v3 are now orthogonal basis vector. But now we are converting orthonormal basis vector. So that's why we are dividing v1, v2, v3 by its norm. So norm v1 is 1, 1, 1. So norm v1 is under root 1 square plus 1 square plus 1 square, that is under root 3. v2 is minus 1, 1, 0. So norm v2 is equal to under root minus 1 square plus 1 square, that is in under root 2, and v3 is equal to under root 1 upon 6 square plus 1 upon 6 square plus minus 1 by 3 square. So that is 1 by 36 plus 1 by 36 plus 1 by 9. So whenever you simplify, that will become 1 upon root 6. Norm v3 is 1 upon root 6. So the required orthonormal basis is given by v1 upon norm v1, v2 upon norm v2, v3 upon norm v3. So 1 upon root 3, 1 upon root 3, 1 upon root 3, that is v1 upon norm v1, v2 upon norm v2, that is minus 1 by root 2, 1 by root 2, 0. v3 upon norm v3, that is 1 upon root 6, 1 upon root 6 minus 2 by root 6. Okay, so here is the answer. This is the required orthonormal basis vector. So we have normal basis vector, we have any basis vector, we are converting that basis vector into orthogonal basis vector using Gram-Schmidt process, and then orthogonal basis vector to orthonormal basis vector, just dividing by its norm, okay, of each vector. So here this question is complete now, and this question asking 4 marks in this question paper. Next question, question 4c. Let W be a subspace of R3 spanned by the vectors W1, that is 1 minus 1 3, W2, that is 5 minus 4 minus 4, and W3, that is 7 minus 6 2. Find the orthogonal complement of W. The space W spanned by W1, W2, W3 is the same as the row space of the matrix A. Okay, so that W1, W2, W3 we are converting into a row vector of the given matrix A. Okay, and the span by the W1, W2, W3 is the same as the row space of the matrix A, that is 1 minus 1 3, 5 minus 4 minus 4, 7 minus 6 2. Now the null space of A. Here is the one theorem that if you want to find the orthogonal complement of W, or orthogonal complement of any matrix, that is exactly the null space of the given matrix. So now the null space of A is exactly the orthogonal complement of W. Okay, indirectly you can say that the null space of A is exactly the orthogonal complement of W, right? To find null space of A, we consider Ax is equal to 0. So that's why 1 minus 1 3, 5 minus 4 minus 4, 7 minus 6 2 into x1, x2, x3, that is equal to 0 0 0. Now we are converting this matrix into a row echelon form. So that's why we multiply first row with minus 5 and add into the second row. We multiply first row with minus 7 and add into the third row. So the first row is as it is 1 minus 1 3 x1. Second row is now 5 minus 5 0, minus 4 plus 5, that is 1, minus 4 plus minus 4 minus 3 into 5, that is minus 15 minus 4, that is minus 19. Similarly, whenever we multiply first row with minus 7 and add into the third row become again 0 1 minus 19. Okay, Now next process is we multiply second row with -1 and add into the third row. First and second row are as it is, 1 minus 1 3. Second row is also as it is, 0 1 minus 19. The third row becomes 0 0 0. Okay, so the third row becomes 0 0 0, and this matrix is in the row echelon form. From this matrix you can find the solution of the Ax is equal to 0. We get three equations: x1 minus x2 plus 3x3 is equal to 0, x2 minus 19x3 is equal to 0. We have leading entry in first and second column. We does not have any leading entry in third column, so that's why we suppose x3 is equal to t. We take x3 is equal to t. Then we have x1 is equal to 16 into t and x2 is equal to 19 into t. So the solution is x is equal to x1 x2 x3, that is equal to 16 19 into 16 19 1 into t. So the basis of the null space of A is 16 19 1, and the space spanned by the vector 16 19 1 is the orthogonal complement of W. So this is the basis vector. 16 19 1 is the basis vector for the space spanned by the vector. 16 19 1 is the orthogonal complement of W, right? Here is, so this is the answer. So 16 19 1 is the basis vector, right, for the orthogonal complement of W. This is the next question, or question 4 is complete. In this question paper, the paper style is question 1 is compulsory, question 2A is compulsory. From question 2B there are options that question 2B or question 2B, then question 3 or question 3, then question 4 or question 4, right? So first question 4 is complete. Now here is the next question 4, that or question 4A. Consider the basis S is equal to V1 V2 V3 for R3, where V1 is equal to 1 1 1, V2 is equal to 1 1 0, V3 is equal to 1 0 0. Let T from R3 to R3 be the linear operator such that T of V1 is equal to 2 minus 1 4, T of V2 is equal to 3 0 1, T of V3 is equal to minus 1 5 1. Find the formula for T of x1 x2 x3 and use the formula to find T of 2 4 minus 1. Okay, again I repeat the question, that we have basis S for R3, we have V1 V2 V3 which are the basis vector for R3. We have transformation T from R3 to R3, and we have T of V1, T of V2 and T of V3, and then we have to find formula for T of x1 x2 x3, right? So now because of V1 V2 V3 are basis vector for R3, so any x1 x2 x3 belongs to R3 can be expressed as linear combination of basis vector of R3. That means if we take U is equal to x1 x2 x3, definitely U can be expressed as linear combination of V1 V2 V3, because of V1 V2 V3 are basis for the R3, okay, by the definition of basis. So U is equal to x1, let U is equal to x1 x2 x3 belongs to R3, then U can be expressed as linear combination of V1 V2 V3. So U is equal to A V1 plus B V2 plus C V3, right? So x1 x2 x3, that is equal to A into 1 1 1 plus B into 1 1 0 plus C into 1 0 0, that is equal to A plus B plus C, A plus B and A. Equating the corresponding components, we get A is equal to x3, A plus B is equal to x2, and a plus b plus c is equal to x1. Put the value of a in the second equation, you will get b is equal to x2 minus x3, and put the value of a and b in the first equation, you will get c is equal to x1 minus x3. Okay, just simple simplification. So now we have a, b and c in term of x1, x2, x3. Now put this value a, b and c in the first equation on the screen. Okay, so now x1, x2, x3 that is equal to a into 1, 1, 1, but what is our a? A is x3. So x1, x2, x3 that is equal to x3 into 1, 1, 1. Okay, x3 into 1, 1, 1 plus b into 1, 1, 0. So x2 minus x3 into 1, 1, 0 plus c into 1, 0, 0 plus x1 minus x3 into 1, 1, 0, 1, 0, 0, and then operate t on both the sides. So you will get this equation t of x1, x2, x3 that is equal to x3 into t of v1 plus x2 minus x3 into t of v2 plus x1 minus x2 into t of v3. So x3 now we have t of v1, t of v2 and t of v3 in the statement of the example, right? So t of v1, you can see t of v1 is 2 minus 1 4. Here t of v1 is 2 minus 1 4, t of v2 is 3 0 1, and t of v3 is minus 1 5 1. So that's why you can put all the values of t of v1, v2, v3. So you will get x3 into 2 minus 1 4 plus x2 minus x3 into 3 0 1 plus x1 minus x2 into minus 1 5 1, that is equal to 2x3. Just multiply x3 into the first vector, so 2x3 minus x3 4x3 plus, now multiply x2 minus x3 into the second vector 3 0 1, so you will get 3x2 minus 3x3 then 0, then x2 minus x3 plus multiply x1 minus x2 into the minus 1 5 1, so you will get x2 minus x1 then 5x1 minus 5x2 then x1 minus x2. Now just add the coordinate wise. The first coordinate in the first vector is 2x3, then so the 2x3 plus 3x2 minus 3x3 plus x2 minus x1, that is minus x1 plus 4x2 minus x3. Just simplification. Okay, it's quite easy to understand. Then minus x3 plus 0 plus 5x1 minus 5x2, so that is 5x1 minus 5x2 minus x3, then 4x3 plus x2 minus x3 plus x1 minus x2, that is minus x1 plus x1 plus 3x3. Okay, so this is the given formula. This gives the formula t of x1, x2, x3. Now we want to find t of 2 4 minus 1. So now we have t of x1, x2, x3. In t of x1, x2, x3, instead of x1, x2, x3, you will put the value of 2 4 minus 1. That means instead of x1 you have to put 2, instead of x2 you have to put 4, and instead of x3 you have to put minus 1. So you will get minus 2 plus 16 plus 1, then 10 minus 20 plus 1, then 2 minus 3, that is equal to 15 minus 9 minus 1. Okay, so this question is complete. Now this question asked in 5 marks. Next question, question 4b. Find the least square solution of the linear system Ax is equal to b, and find the orthogonal projection of b onto the column space of A, where A is equal to minus 2 minus 2 1 1 3 1 and B is equal to the column vector 2 minus 1 1. This question asked in 5 marks. The solution: the least square solution x caret of ax is equal to b satisfied the normal equation. This normal equation A transpose into A into x caret, that is equal to A transpose into B. Put all the values, that is we have A, so you can find A transpose. The A is in form of 3 cross 2, so A transpose in form of 2 cross 3, right? Just interchanging the row and column. So A transpose is 2 1 3 minus 2 1 1, A is 2 minus 2 1 1 3 1, x caret is x1 x2, that is equal to A transpose 2 1 3 minus 2 1 1 into B, that is 2 minus 1 1. Okay, now just multiply first two matrices. How to multiply two matrices, that you should know, that how to multiply two matrices. The first matrix is in form of 2 cross 3, okay, and the second matrix is in form of 3 cross 2. So let's see how to multiply that two matrices. Just try to understand. Here is the two matrices 2 1 3 minus 2 1 1 into 2 minus 2 1 1 and 3 1. This matrix in form of 2 cross 3. This matrix in form of 3 cross 2, right? Is it multiplication of any two matrices is possible? No. The answer is no. The correct answer is, whenever you multiply AB, the matrix AB, the number of column in the first matrix, that is exactly the number of row in the second matrix.